A large clinical trial of the effective diet on breast cancer assigned women at random to either a normal diet or a low-fat diet. To check that the random assignment did produce comparable groups, we can compare the two groups at the start of the study. Ask if there is a family history of breast cancer. 3396 of the 19541 women in the low-fat group and 4929 of the 29294 women in the control group said yes. If the random assignment worked well, there should not be a significant difference in the proportion with family history of breast cancer. Well, yeah, because if you have, even if you are on a low-fat diet versus a normal diet, that doesn't indicate what happens in previous generations, right? So yeah, there shouldn't be a significant difference, right? So they're saying that if our null hypothesis, right, is going to be that there is no difference between the proportions, right? We should fail to reject the null hypothesis. That's what it's saying, right? A, how significant is the observed difference? Carry out an appropriate test to help answer this question. And part B, describe a type 1 and type 2 error in this setting, which is more serious. So we want to perform a test at the alpha equals 0.05 significance level. Because they didn't give us a significance level, we just assume it's 0.05. And our null hypothesis is that there is no difference, which is what they're saying we should get, versus an alternate hypothesis, which is saying there is a difference. Of course, where P1 is the actual proportion of women in the low-fat group who had a family history of breast cancer, and P2 is the actual proportion of women in the control group who had a family history of breast cancer. All right, so the plan is we should do a two-sample z-test for P1 minus P2 if the conditions are met. So this was a random experiment, so that's conditions fulfilled. Now normal, as you can see, I carried out the calculations already. So N1 times P1 hat is going to give me 3396, which is greater than or equal to 10. This calculation is going to be bigger than 10. This calculation is going to be bigger than 10. And this calculation is going to be bigger than 10. So our normal condition is met. Now our independent condition, so capital N1 is going to be all women on a low-fat diet, and N2 is going to be all women on a normal diet. So you can pretty much see that this is going to be fulfilled, right? Because remember, it's N1, it has to be less than or equal to a tenth of capital N1, and N2 has to be less than or equal to a tenth of capital N2. And remember, N1 was that 19541. And of course, that's less than a tenth of all women on a low-fat diet, right? And what was N2? N2 was that 29294, which of course is less than a tenth of all women on a normal diet. So all the conditions are met. Now let's go ahead and do our test. So here's N1, and then we did the calculation for P1 hat for the decimal representation. So remember, it was 3396 over 19541, which is 0.174. And then N2 is 29294, and P2 hat was 4929 over 29294, which give us the sample proportion of 0.168. So let's go ahead and calculate the pooled proportion. So N1 times P1 hat. So N1 times P1 hat was 3396. So 3396 plus, and then N2 times P2 hat was 4929. 4929, and that's all over 19541 plus 29294, which gives me, let's see, that would give me 0.170, okay, or just 0.17, right? So now that we have our pooled proportion, we can come up with our test statistic, right? So remember, P1 hat was 0.174, 0.174 minus, and then 0.168. Our null proportion was 0, and that's all over the square root. Our pooled proportion was that 0.17 times 0.83 over N1, which was that 19,541, plus 0.17 times 0.83 times 29,294. And then if I do this calculation, this will give me a 1.73. All right, since this is a two-sided test, we know the p-value is equal to 2 times the probability that C is bigger than 1.73. Of course, for our table, we need to rewrite this as Z less than or equal to 1.73. And the way we do that, this will be 2 times 1 minus the probability that Z is less than or equal to 1.73. And now, let's go to our table to find 1.73. As you can see, I already highlighted it here. Here's my table. So 1.73 is 0.9582. So this is 2 times 1 minus 0.9582. And this will be 2 times 0.0418, which is 0.0836, which, you know, this is not less than our significance level of 0.05, so we will have to fail to reject the null hypothesis, right? So indeed, it did come to pass that, that we failed the null hypothesis. So, since the p-value is 0.0836, which is not less than alpha, which is equal to 0.05, we failed to reject H naught, which stated that there is no difference between the proportions, right? We do not have enough evidence to conclude that there is a difference in the actual proportion of women in the two groups who have a family history of breast cancer. And this is, for sure, this does make sense. So a type 1 error would be to say that we reject H naught when H naught is true. So we would that we would reject H naught when H naught is true. Thus, we say that there is a difference between a woman on a regular diet versus women on a low-fat diet when there is none, right? So we say there is a difference when there isn't, right? A type 2 would be to say that we fail to reject H naught when H naught is false. Now, this is really bad because this says that there is no difference between women on a regular diet versus women on a low-fat diet when there is, right? So this would be really bad. So a type 2 error is more severe since there is a potential for these women to not obtain breast cancer through their diet choice.